Hi everyone, this is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So today I want to discuss about shear force and bending moment. So already in previous sessions we have discussed about solid mechanics and materials. So in this we have learned stresses, different types of stresses, and strain, the relation between stress and strain, and then relations between the various elastic constants, and how to calculate the stress and strain, and what are the stresses in composite bars, and whenever the object is subjected to thermal loading, so the how to calculate the thermal stresses, so we have discussed. So in this topic, the main topic is the shear force and bending moment. So in the shear force and bending moment, first of all, we have to study. So what do you mean by the shear force, and then what is this bending moment, and then what are the various loads, and then how many the shear force, how many beams are involved in this shear force and bending moment topic. So before starting this shear force and bending moment calculation, you should know about beam and types of beams. So here the outcome at the end of the course, the students should be able to illustrate the shear force and bending moment distribution diagrams for analyzing the structural behavior under various loads. So the outcome is shear force, illustrate the shear force and bending moment distribution in beams. After completion of this topic, the student should be able to illustrate the shear force diagrams for different beams, and also they can analyze the structural behavior under various loads. So first we will see the beam definition and the types of beams. The concept of various types of beams and form of loading. Different types of loading are there. So first we will discuss about the beam. So what do you mean by beam? A beam is a structural member used for bearing loads. It is typically used for resisting vertical loads, shear forces, and bending moments. It is a structural member. Suppose example, the beam is like this. It is said to be a beam and used for to carry the loads like this, different types of loads, resisting vertical loads, shear forces, and bending moments. Clear? So types of beams. According to the nature of supporting edges, and according to the nature of loads, the beams are classified into different types. One is simply supported beam, and second one cantilever beam, third one overhanging beam, fourth one continuous beam, and a fixed beam. These are 5 types of beams. So one by one we will see the definition and the construction of these beams we will see in this session. So types of beams. First one is simply supported beam. So what is this simply supported beam? A simply supported beam is a type of beam that has pinned support at one end and roller support at the other end. Depending on the load applied, it undergoes shearing and bending. It is the one of the simplest structural elements in existence. A simply supported beam is a type of beam. So that has pinned support at one end and roller support at the other end. The shearing and bending depends upon their load applied. So very simplest structural element. So see in this diagram shown the simply supported beam has pinned support at one end pinned support and other end is rollers. This is a beam. These two ends are supported. This type of beam is simply supported beam. It carries loads, different types of vertical loads and UDL loads. So I will tell you in next session what is this UDL and vertical forces. Next one is cantilever beam. Cantilever beams a structural member of which one end is fixed and other end is free. So this is one of the famous type of beam used in trusses, bridges and other structural member. This beam carry load over the span which undergoes both shear stress and bending moment. The one end is fixed, other end is free. This is mostly used in the bridges and trusses. So the beam carry load over the span. So I will show you diagram. So this is cantilever beam. One end is fixed, another end is free. Suppose the load is acting like this. The load also act like this UDL. This load is uniformly distributed load. And this load is point load. So as per the construction details, one end is fixed, other end is free. So mostly these type of beams are used in trusses and bridges. Next, overhanging beam. The overhanging beam is combination of simply supported beam and cantilever beam. The combination of these two. Simply supported beam already we have seen in the first slide. Both ends are supported. In cantilever beam also we have seen. One or both of end overhang of this beam. either one or both of end overhang. This beam is supported by a roller support between two ends. This type of beam has heritage properties of cantilever and simply supported beam. So the overhang beam is shown in this figure. One end is fixed, other end is free. This is have seen in simply supported cantilever beam. Cantilever, and this one is two ends are, one is supported and another end is roller. This is simply supported beam. Simply supported. So the combination of these two, simply supported plus cantilever beam, gives overhanging beam. The some portion of the beam overhanged. Here you can see this portion overhang, not supported from this from here to roller support to this free end. With some x distance. This is overhanging beam. Next one is continuous beam. So this beam is similar to simply supported beam, except more than two support are used on it. One end of it is supported by hinged support and the other one is roller support. One or more supports are used between these beams. It is used in long concrete bridges where length of bridge is too large. This beam is similar to simply supported beam, except more than two supports are used on it. So like in simply supported, one end is supported, other end is hinged, and the other one is roller support. See, continuous beam, this end is supported with roller support. Hinged support and then roller support. Here, how many supports are there here? 1, 2, 3, and 4. See, more than two supports are used on it. So one or more supports are used between these beams. These type of beams are called as continuous beams. It is used in long concrete bridges where length of the bridge is too large. So total 4 supports are used. Next, fixed beam. This beam is fixed from both ends. So here see, the both ends are fixed. It does not allow vertical movement and rotation of the beam. There is no vertical movement And rotation of the beam also, the rotation of the beam also not allowed. It is only under shear stress and no movement produces in these beams. It is used in trusses and other structures. Both ends are fixed. This type of beams are used in trusses. So up to now, we have seen beam. What do you mean by beam? And then types of beams. In types of beams, you have seen simply supported beam, cantilever beam, and overhanging beam, and a continuous beam and fixed beam. So that actually the beam is a structural member used for bearing loads. We have studied. It carries number of forces, number of loads. It may be vertical loads, depending movements on these beams. So according to the depends upon the nature of load and nature of supports divided into these types: cantilever beam, overhanging and continuous beam and fixed beam. And also we have seen the diagrams for simply supported beam and then cantilever beam and then overhanging beam and continuous beam, and types of beams. The continuous beam also shown in this figure. The types of beams: fixed beam. Next one is types of loading. The concept of various types of beams we have seen. Now the types of loading are: the beam is usually horizontal member and load which will be acting over the beam will be usually vertical loads. Suppose one cantilever beam is there. Why it is said to be cantilever beam? One end fixed and other end is free. So whatever load acting, the load is vertical loads. They are following types of loads are as mentioned here, and we will discuss each type of load in detail. So over the beam, the vertical load, it may react like this. In simply supported beam, types of loading, simply supported beam, the load acting at its center. So usually the loads are vertical loads. So different types of loads, we will see the type of loading. One is point load or concentrated load. Those loads are called as point load. These are all are point loads. So directly acting at a point. Suppose you are acting at its midpoint, mid span. Uniformly distributed load and uniformly varying load. The point load or concentrated load, the load is concentrating at a particular point, are uniformly distributed. Throughout the span beam, the load will be distributed. Similarly, uniformly varying, the load is varying gradually, increasing or decreasing uniformly. So now we will discuss about first load, point load or concentrated load. The point load or concentrated load, as name suggests, act at a point on the beam. If we will see practically, the point load or concentrated load also distributed over a small area. but we can consider such type of loading as point loading, and hence such type of load could be considered as point load or concentrated load. So in this diagram shown this point load or concentrated load. So the following figure displayed here indicates the beam AB of length L, which will be loaded with point load W at the midpoint of the beam. Load W will be considered here as the point load. See, so in this the beam length is AB loaded with point load W at the midpoint. Why it is said to be point load? The concentrated at this point only. But in practical, the concentrated load also distributed over a small area, but we are not considering. Suppose in this beam, the load is acting here. So here some small area it occupies. But we are not considering. Consider as a point load or a concentrated load. Next, uniformly distributed load. So uniformly distributed load is the load which will be distributed over the length of the beam in such a way that the rate of loading will be uniform throughout the distribution length of the beam. So uniformly distributed load is the load which will be distributed over the length of the beam. See here, see, same beam again taken here, AB, the length is L. So here the load is distributed throughout its beam, not at a particular point. The rate of loading will be uniform throughout the distribution length of the beam. The rate of loading, Newton per meter. So you can represent the ideal load like this also. So this is W is Newton per meter. So in the case of previous case, the load is acting at a point that is W. Next, uniformly distributed load is also expressed as UDL and with value as W Newton per meter, the UDL. During determination of the total load, total uniformly distributed load will be converted into point load by multiplying the rate of loading, that is W Newton per meter, with the span of load distribution. That is, Ln will be acting over the midpoint of the lengthen of the uniformly load distribution. See, so when this load is considered as a UDL, right, uniform distributed load, but by solving problems, calculating loads, this uniform distributed load converted into point load. So multiplying the rate of loading. So here shown the diagram. Let us consider the following figure. The beam AB of length L is loaded with uniformly distributed load. The rate of loading is Newton per meter. The total uniformly distributed load is P is equal to W multiplied with L. So W is here Newton per meter. Load, the rate of loading, and the length of the beam. So the total uniformly distributed load is W into L. So the distributed load converted into point load. It's a uniformly varying load. So uniformly varying load is the load which will be distributed over the length of the beam in such a way that the rate of loading will not be uniform but also vary from point to point throughout the distribution, the length of the beam. So the uniform varying load is distributed over the length, but the rate of loading will not be uniform. See, in previous case, the rate of loading is from starting to ending, the maintaining uniformly. So uniformly distributed. From one end to another end. But in case of varying load, not distributed uniformly, also vary from point to point throughout the distribution length of the beam. So the uniformly varying load is also termed as triangular load. See, I will show you a diagram. This is a uniformly varying load from 0 to the maximum, that is W, not uniformly distributed. So the length of the beam is L. The load is Newton per meter. So how do you convert this uniformly varying load into point load or concentrated load? How do you calculate P? So in normal distribution, normal UDL, so P is equal to W into L. So W is here the rate of loading multiply with length. But in this case, the AB, the beam, the L length beam is loaded with uniformly varying load. We can see from the figure load is 0 at one end and increases uniformly to the other end. During determination of the total load, we will determine the area of the triangle. And the result, that is area of the triangle, will be total load, and if this total load will be assumed to act at the center of gravity of the triangle, that is P is equal to W into L by 2. So how do we calculate this uniformly varying load? So this is a triangle. So how do we calculate the area of the triangle? Area of triangle of base into height. You know. So the center of gravity assume here for triangle that it's center is L and H. So here the load is started at 0 and increases uniformly to the other end. So 0 and increase up to W. From point to point, they vary. The load vary. So now in this case, the determination of area of the triangle, that is multiplied with load, will give total load acting on this uniformly variable load, uniformly varying load. So P is equal to area of the triangle. So that is half into W. So base is L. So here W is Newton per meter. So that the total load P is equal to WL by 2. So here the load is converted into the distributed uniformly distributed load, that is UDL, converted into point load. See, the distributed load units are Newton per meter. While calculating total load of into this W multiplied with L. So what are the units of W? Newton per meter. And the rate of load per meter multiply with the length, the beam length units are in a meter. So meter get cancelled here. The units are in newtons. So that this distribution load converted into normal load. So like this, you need to calculate various loads while solving the problems of shear force and bending moment. So now in this, the second topic, the types of loading we have learned. The point load and the constant load. What is the difference between the point load and the uniformly distributed load? And a uniformly varying load. So uniformly distributed load, uniformly distributed throughout the beam. So this is only difference is varying. Point to point vary. 0 to maximum value, it will be increased. So beams work, and then have seen ideal point load and concentrate load. So in this, the point load and concentrate load, here you can calculate total load acting on this beam. Suppose here acting only one load. Suppose here acting more loads. Clear? So here, suppose in this, the more loads are acting in a cantilever beam. So with a distance L1 and L2 and L3. So here, one load acting at L1, the second load acting at L2 and L3. So W1 W2 and W3. These are point loads. So now, how do you calculate the total load acting on the beam? The total load acting on the beam is W1 plus W2 plus W3. So whereas an uniformly distributed load, suppose these loads are not point loads, uniformly distributed load, like this. Then W1, W2, W3. So here, how do you calculate the in the case of uniformly distributed load? The loads are now calculate P is equal to the triangle load W multiply with L1 plus half into W2 into L2 plus half W3 into L3. So you will get a total load on the beam in the case of uniformly varying load. In the case of uniformly distributed load, total load is, I will draw here, the total load is P is equal to W into L1 plus W into L2 plus W into L3. You need to multiply with the distance. So whereas in so like here shown W uniform distributed load W into L, length L. Varying load, so in this, see the diagram shown here like this, but in previous example I will show you up to here L1, up to here L2 and remaining L3. The load is W. So in this case, see W. So take divide into different portions L1 and L2 and L3. So in this case, apply this. P is equal to half multiply with W1 L1 plus W2 L2 plus W3 L3. So the load also will vary and at the same time the length also vary. At different lengths of the beam, the load also vary. The load acting with different loads, the different areas. So like this, how to calculate according to the nature of the loads. For this PPT, have taken references as Ramamrutam. The title is Strength of Materials, and R.K. Rajput Strength of Material. Publishers are Achan and New Delhi. Dhanpati Rai publishes Ramamrutam, and R.K. Bansal, textbook of strength of materials. Lakshmi Publications. And then R.S. Kurmi and Gupta, the title of the book is Strength of Material. Hassan and Co. Publications. So these are references I have taken for this PPT. So you can refer these textbooks for more information. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.